So today we begin our lesson, and we are continuing with calculus. Yesterday or the previous lesson we introduced. So today I want us to look at something called partial differentials. Partial differentials. Partial differentials. And partial differentials. Tracy, good morning and welcome. Partial differentials occur where you have one function that has more than one independent variables, and you are told to differentiate it. So as usual, we begin with an example here. Example 1. Example 1. You are given a function. You are given a function called TC is equals to 10 plus 3x squared plus 2y squared plus 2xy. You are given a function like that. Now to get the partial differentials, we say the differential of the total costs with respect to x, because x is the first one. So this one does not have x, so it becomes 0. This one has x, so it is 2 times 3, that gives us 6. When you less 1, you're just left with 1, so 6x. This one does not have x, so it becomes 0. This one has x, so raised to power 1. So 1 times 2y, we are left with 2y. So b settled as 6x plus 2y. The second part is you differentiate the TC with respect to y. With respect to y. So this one does not have y, so again it becomes 0. This one does not have y, so it also becomes 0. This one has y squared, so 2 times 2, that gives us 4. When you left 1, you're left with y. This one, we have y raised to power 1, so 1 times 2x, we are left with 2x. And in so doing, this becomes 4y plus 2x. 4y plus 2x. So that is what we call partial differentials, because you differentiate this function in parts. You differentiate it in parts. You differentiate it in parts. Each part with respect to the independent variable. Each part with respect to the independent variable. So if that is true, let's have example 2. Example number 2. Example number 2. If we are given a function, we are told C is equals to x squared plus 2y squared minus xy. We are given a function like that. The partial differentials will be the differential of C with respect to x. When you start with x, now this one has x squared, so it's going to be 2x. This one does not have x, so it becomes 0. This one has just one x, so x raised to power 1. So it will be just 1 times y. You get y. So the answer will then settle as 2x plus y. 2x plus y. The differential of the total cost with respect to y. You differentiate with respect to y. Now this one does not have y, so it becomes 0. This one has y, so you multiply 2 by 2, that gives you 4y. This one has 1y, so you multiply, and sorry, this one should have been negative. Should have been negative, adjust, should have been negative. So this one becomes minus x. So this one is 4y minus x. 4y minus x. Okay, the next thing that we need to mention is called presence of constraints. Presence budget constraint. Now, as you can see in the notes, a budget constraint is simply a resource that is scarce. A resource that is scarce. So what we do, we create a Lagrange function. We create a Lagrange function. So here we say L is equals to f of xy plus lambda g of xy, where L is called Lagrange function. Lagrange function f of xy is the function to be maximized or minimized, depending on what it is that you are looking for. Then g of xy is the function for the budget constraints. G of xy is the function for the budget constraints. And this lambda here is changing f of xy when g of xy changes by 1. This is like the slope. Changing fxy when g of xy changes by 1 unit. So in that case, I want us to have an example 1. Example 1. Example 1. Now in this example 1, we are told that X costs shillings 10 per unit, and product Y costs shillings 15 per unit. Produce the amount available is shillings 850. The amount available is shillings 850. Profit function is pi is equals to $60x plus 150y minus x squared minus 3y squared. So at what values? At what values of x and y? Of x and y will profits be maximum? Will profits be maximum? What points will the profits be maximum? So in the solution, in the solution, g of xy, that is the Banach constraint, g of xy is assume that we are making x units. So it will be x times 10. That's the cost of making x. So it will be 10x. And we are making y units. So y times 15. So it will be 15y. Now the amount of money we spent should be equal to 850 or less than 850. Because that is the maximum money that is available. So what you do, this one changes to 10x plus 15y minus 850. Because we should have just one equal sign. So in a cross over. Then the f of xy, is the function for the profit that we want to maximize, which we are told is 60x plus 150y minus x squared minus 3y squared minus 3y squared. So there are grades which we have already said should be f of xy plus lambda g of xy plus lambda g of xy. It is going to be L is equals to 60x plus 150y minus x squared minus 3y squared plus lambda. Now lambda of gxy, that is 10x plus 15y minus 850. Minus 850. So L becomes, you open the brackets, you get 60x plus 150y minus x squared minus 3y squared plus 10x lambda plus 15y lambda minus 850 lambda minus 850 lambda. Minus 850 lambda. Now for maximum profit, if you differentiate these grades, you can see now this one has 3 independent variables. Tuko na x, tuko na y, na tuko na lambda. So the differential of the grade with respect to x should be equal to the differential of the grade with respect to y, should be equal to the differential of the grade with respect to lambda, and all of them should give us 0. They should be 0. So if they should give us 0, that is, let's start here. The differential of the Lagrange with respect to x. With respect to x. This one has x raised to 1, so it will become 60. This one does not have x, so it becomes 0. This one has x, so it becomes minus 2x. So this one becomes minus 2x. This one does not have x, so it becomes 0. This one has x raised to 1, so it's going to be 10 lambda. So plus 10 lambda. This one does not have x, and this one also does not have x, so they become 0. So you tell us this should be equal to 0, and you call it equation number 1. Call it equation number 1. Then the differential of Lagrange with respect to y. The differential of the Lagrange. Remember, these are partial differentials. They are partial differentials. So this one does not have y, so it becomes 0. This one has y, so it becomes 150. This one does not have y, 0. This one has y, so it is 2 times 3, it becomes minus 6y. This one, no y, so it becomes 0. This one has y raised to 1, so 1 times 15, so it becomes plus 15 lambda. And this one does not have y, so it becomes 0. And this one we call it equation number 2. Call it equation number 2. And when it becomes equation number 2, I proceed and say the differential of L with respect to pi. The differential of L. So now I want to differentiate this with respect to pi. Now this one, this one, this one, and this one, they don't have pi, so they all become zeros. But this one has pi raised to power 1, so it's going to be 10x. This one, it has pi, so it's going to be 15y. And this one has pi raised to power 1, so it becomes minus 850. And you tell us that is equals to 0. You call it equation number 3. Question number 3. So, when you have those 3 equations, we can decide to move pi, moving pi from equation 1 and 2. So, removing pi from equations 1 and 2, from equations 1 and 2, you are going to have now this 60, I can take it to this other side. So that I'm left with minus, I'm going to first of all bring it the way it is. 60 minus 2x plus 10 lambda is equals to 0. Then 150 minus 6y plus 15 lambda is equals to 0. Now you can see that lambda, the coefficients are not the same. And I told you the easiest way to remove is to multiply by the opposite coefficients. So here I multiply by 15, and here I multiply by 10. By 15 and by 10. So if I say 60 times 15, I get 900 minus 30x plus 150 lambda is equals to 0. This one will be 1,500 minus 60y plus 150 lambda is equals to 0. Now this one you can go this way. You can go the way it is there. But maybe to avoid a lot of questions, you see here we do not have y. And here we do not have x, but we want to subtract. So it's like this equation, it is 900 minus 0y minus 30x plus 150 lambda is equals to 0. Then 1500 minus 60y, this 0 numerator, so that huyu y, this y here, tupate mwenzake hapa juu. Because now that it is not here, ni kumaanisha it is 0. The same thing here, pili haina x, so I can bring minus 0x. So that it will match with this one. Plus 150 lambda is equals to 0. So I hope you have understood that concept. Hapa hatuna y, so I bring 0y. You imagine a y. Hapa hatuna x, so I bring 0x. You imagine a this. So if now I come here and say subtract 900 minus 1500, if you do that overhead, or you consult your calc, it will tell you minus 600. Then minus 0 minus 60, that would be positive 60y. And this one will be minus 30x being equal to 0. And this one, I will call it equation number 4. We call it equation number 4. So I now proceed, and this equation number 4, I will now say removing x from equations 3 and 4. Removing x from equations 3 and 4. You see this equation here? I have 10x plus 15y. I can say this one here to the other side, putting items together, 850. And I do the same here. So hii minus 600 ikienda huku nitaachwa na minus 30x here plus 60y is equals to 600. It's equals to 600. Is equals to 600. So in order for my coefficient to be the same, you see these ones. So I will come here. Here I multiply by 30 and here I multiply by 10. So 30 times 10 is 300x. 15 times 30 is 450. Plus 450y. 850 times 30 is 25,500. Then this one becomes minus 300x plus 600y is equal to 6,000. So I want to remove this x. So because they are connected by opposite sides, what I will do is to add here so that x will disappear. And here I'm left with 1050y is equals to that 1,500. So from there, I should be able to get y with that 1,500 divide by 1050. That. So y is that units. Now substituting in equation 3. In equation 3 or even equation 4. So if I come to equation 3, I will say 10x plus 15 times 30 is equal to 850. So 10x is 850 minus 450. So 10x is equal to 400. And therefore x must be 40 units. And hence, you will get the maximum profit. So we are not going to bother to solve radar. That is good enough. We've got to memorise after hii na hii. So the maximum profit What you do, you put these values of x and y in the equation that was for the profit. By the equation was 60x. So 60 times 40 plus 150y. 150 times 30 minus x squared, that is 40 squared, minus 3y squared, 3 times 30 squared. So get your answer there. Because of the interest of time, we cannot be able to handle another one. But what I will do is to give you an assignment here. The question of May 2018. May 2018. Question 2B. So you can attempt that one on your own. It is exactly like this one. So once you have understood this, you can attempt that assignment. So, so that now we proceed and look at integration. Proceed and look at integration. Now, integration, when we talk about the integration, we are talking of combination. Combining, bringing together. We are talking of the totals. We are talking of the sum. And there are three methods that can be used to get the total. Methods to get total. You can either add or you can multiply or you can integrate. If you're asked to get the total of anything, you can add 3 plus 2 is 5. That is a total. You can multiply 2 times 3 is 6. And what you should notice is that the 3 methods do not give the same answer always. Like when we say 2 times 3 is 6. 6 is a total. And 2 plus 3 is 5. 5 is also a total, but you can see they are different. And the same case will apply with integration. So which method to use where depends on what has been given. We use integration where we have been given margin. Why do we talk of that? It is because this is the reverse of differentiation. Integration is the reverse of differentiation. So if you have understood what you have been doing, then that becomes very, very easy for you, Santi. We have 2 types of integration. The first one is called indefinite integration. Now, indefinite integration, it is where we do not have limits. It's where we do not have limits. So if you are told that example 1, you are told to integrate 3x squared with respect to x. Ukiandika hiyo kasebo hiyo inakaa elongated s, this one means to integrate. The solution is that y equals, you first of all copy this function, the it is 3x squared. If you remember what you are doing with differentiation, you are first of all multiplying, then subtracting. So to reverse, we will add and divide. So you add 1 here, here to be told. Then you divide by the new power here, 2 plus 1. And we always add c. Now that c is called constant of integration. And it's supposed to present any constant that became 0 during differentiation. So this settles that this one cancels, x cubed plus c. If you know the value of x and the value of y, you substitute them there to get the value of c. But if you do not know, you just leave it. When you're dealing with a revenue function, c is always 0. And when you're dealing with a cost function, c is always the fixed cost. Those things are in your notes that I gave you. So example 2. If you are told to integrate 4x cubed plus x plus 8 with respect to x, with respect to x, the solution is that y is equals to y equals to, you take this 4x cubed, you first of all add back 1, then you divide by the new power, 3 plus 1. You say plus x, which is currently raised to power 1. You add back 1. You divide by the new power, 1 plus 1. Plus 8, which is currently x raised to power 0. You add back 1. You divide by the new power, 0 plus 1. And you add the constant of integration c. You add the constant of integration c. Sasa, this settles as y is equals to these 3, these 4. We are left with x raised to power 4 plus x squared out of 2 plus 8x plus c. So that is what you get. Example 3. Example 3. We are told to integrate 10x cubed minus 4x raised to power minus 3 plus 16x minus 18. This with respect to x, dx hiyo inasomwa with respect to x. With respect to x. So the solution to that is that y will be equal to, you take this one, 10x cubed, you add back 1, you divide by the new power, 3 plus 1. Minus 4x, you raise power minus 3. You add back 1. You divide by the new power, minus 3 plus 1. Plus 16x raised power 1. You add back 1. You divide by the new power, 1 plus 1. Minus 18 here, which is currently raised to power 0. You add back 1. you divide by the new power. And then you add the constant of integration C. So this proceeds on to become y is equals to 10x raised to power 4, you divide by 4. This one comes plus because of this negative, these two. So it's 4x raised to power minus 2, you divide by 2. So this negative matches with this, they become positive. Plus 16x raised to power 2 out of 2. Minus 18x plus c. So you can leave it that way, or you can choose to simplify. You can leave it that way, or you can choose to simplify. That is about the what we have called indefinite integration. Then there is something else called definite integration. Definite integration. Definite integration. Now, definite integration, it is where you have some limits, and it's normally given like this. Integrate between A and B, f of x, that way, with an apostrophe there. This is a differential. It should give you f of b minus f of a. In other words, if you are to draw a small diagram, it will ask you that. You are to draw a small diagram. This is the function f of x. So this is the value of a. And maybe I need to come here and say this is equal to area. We normally call it area. So we are looking for this area here. This one. That is bounded here by A, which is the lower limit. And here by B, which is the upper limit. The upper limit. And this is the curve or the function. This is x-axis. And this is your y-axis. So this area would represent anything. It could be profits. It could be total costs. It could be sales. It could be actual area like they do in construction. And so on. So if you are told to have example 1 here, example 1, we want example 1. This example 1, you are told to integrate between 2 and 4 over 2x with respect to x. Integrate between 2 and 4, 2x with respect to x. So the solution to this, we normally say area equals. You take this function iko hapa ndani, it is currently 2x. So you raise it to power 1 and you add back 1. You divide by the new power, 1 plus 1. But here we do not add the constant of integration. Instead, what you do, you draw a straw by that one. And then you write 2 here and 4. So hii kastroke hivi inasomwa in the range of 2 to 4. In the range of 2 to 4. So if we are in the range of 2 to 4, you proceed and say, this will cancel this. You have to achieve x squared in the range of 2 to 4. In the range of 2 to 4. Sasa, you proceed and say x squared. You take this 4, so 4 squared. You minus, you now put 2. So 2 squared. That is what we said here, FB minus FA. So if you take 4 square, you raise 2 square, or let me first of all give 4 square is 3, 2 square is 4, so the answer should be 12. So the answer should be 12. That is how we go about it. Example 2. Example number 2. We are told to integrate between 1 and 3. 4x cubed plus 10x minus 17 with respect to x. We are told to do that. The solution is you come and say area equals. Area equals. You take this one, 4x. Currently is power 3. You add back 1. You divide it by 3 plus 1. Then you say plus 10x. Currently is power 1. You add back 1. You divide by 1 plus 1. Minus 17, which is current 3 raised power 0. You add back 1. You divide by the new power. 0 plus 1. Now this one is in the range of 1 to 3. Is in the range of 1 to 3. So sasa, this proceeds on to become, these 4 cancels, we are left with x raised power 4. These 2 cancels, this one, we are left with plus 5x squared minus 17x in the range of 1 to 3. In the range of 1 to 3. Sasa, you now substitute 1 and 3. So utasema 3 raised power 4 plus 5 times 3 squared minus 17 times 3. You minus 1 raised power 4 plus 5 times 1 squared minus 17 times 1. So you take your calc and get those answers. Tuseme 3 raised power 4 plus 5 times 3 squared minus 17 times 3. This one I'm getting 75. I minus 1 raised to power 4 plus 5 times 1 squared minus 17 times 1. I'm getting minus 11. So if that is true, then this should be 86. That should be 86. Let's have example 3. Example 3. You say integrate between 3 and 5. 12x raised to power 3 minus 4x plus 10. We are given like that. So solution is area is equals to you take this one 12x 3 plus 1 divide by the new power 3 plus 1 minus 4x raised to power 1 you add back 1 divide by the new power 1 plus 1 plus 10x raised to power 0 you add back 1 divide by the new power 0 plus 1 in the range of 3 to 5. In the range of 3 to 5. So this proceeds on to become, this will be 4. So 3x raised to power 4 minus 2x squared plus 10x in the range of 3 to 5. In the range of 3 to 5. So 3 times 5, which is raised to power 4, minus 2 times 5 squared, plus 10 times 5. You say minus 3 times 3 raised to power 4 minus 2 times 3 squared plus 10 times 3. So if you take your calc, you are going to have 3 times 5 raised to power 4 minus 2 times 5 raised to power 2 plus 10 times 5, getting 1875. Then I say minus 3 times 3 raised to power 4 minus 2 times 3 raised to power 2 plus 10 times 3. I'm getting 255. So 1875 minus my answer is 1620. So that is all about the integration. So we are going to call it a day at that point. In our next 2 lessons now, we shall do past paper questions to handle the applications, because now we have exhausted everything. We have now an idea. So tukipata swali that combines various items, now we can be able to handle. And that is what we shall do in our next lesson. Thank you.